Great. So you'll have to scroll. I apologize.
Can I just?
Yeah, I can also tell you. You can tell me to say
there
next
we go.
slide. I can be your manual slide.
Cool.
Okay, great.
That works.
I'll sit down, but less obvious.
All right, cool. Hi everyone, my name is Oleg Andreyev. I'm from Okta. Currently, my focus is in continuous integration, where I co-lead our test frameworks, test toolings, quality, ensuring that we get our releases out efficiently, confidently supporting all of the features within the Okta platform. Previously, I was doing quality for features related to fingerprints, FIDO2, security protocol before that, legacy authenticators, password security keys, email and stuff. Anyway, today I'll be talking about the art of managing flaky tests at scale from my experiences at Okta. So let's dive in. In this talk, we'll talk about the tooling that we use to detect flaky tests, how to improve its visibility from the visibility of technical debt at the organizational level, and then we'll wrap up how these two topics converge and some takeaways. So the focus of my talk is the Okta platform, namely the monolith. It has about 180,000 tests across all the test types. Prior to changes getting released to customers, all tests must pass, no exceptions. A set of internal tooling works to detect, exclude, and notify the test owners when tests reach a target flakiness threshold within our CI system. The time it took, yes. Oh, sorry, I should probably tell you.
Yes.
I will do better about that. The time it took for developers merging their code was increasing, and executive sponsorship initiatives were spurred up to improve that experience. So our architecture enables that features, hotfixes, they can be probably rolled out to our customers, but we have the constraint that every change, every test must pass before going to the customers. So conundrum. The flaky tests, obviously, they reduce the confidence of automated testing. They decrease the CI experience for every engineer, and they're costly to your organization. What time is it?
You have about 15 minutes.
Cool. All right. Next slide. Thank you. In 2023, we focused heavily on CI system efficiency. We to improve the speed of merging code. We reached that goal, but developers were able to merge their code 50% faster. Great. One of the levers that we used to accomplish this goal was we reduced the threshold of our flaky test automation, our application. So as we increase the flaky test count, as we increase the flaky tests and decrease the thresholds, we noticed that teams were disabling tests more frequently, disabling a subset of tests. In aggregate, it increased significantly. So recall that these tests did not get more flaky in 2023 per se. We just decreased the thresholds, right? So in 2024, we focused on that initiative to improve our CI quality, improve loss confidence in test automation, CI system, and testability generally, right? So why in art? Well, writing code is only one part of the equation. Technological problems within systems can be solved by people. We have incentives and everything like that. So we need to take account of how we're driven. How do we balance efficiency and getting the goal while convincing people to do the right thing instead of the easy thing? So we updated internal guidance. We created video written references, video tutorials, like literally step-by-step guidelines on how to fix classes of test failures. That wasn't enough. So kind of took another approach, a little social approach, right? We leaned on the power of incentives, friendly competition, leaderboards, raffles, shout outs. They started to kind of create like a favorable result in our organization. So we'll talk about the tooling. Now we'll talk about the tooling and the integrations behind it. Background is, this auto guardian, it runs constantly. We have configurable, customizable thresholds and 2 levels of Flaky tests. It works to detect, exclude, and notify those test owners. Slide. Here we look at auto guardian visualized. So test run statistics, failures, reruns, runtimes, and so forth, they all get thrown into auto guardian. Depending on the configurations that we have set in auto guardian, we do different things with different test types. So P0s are like build breakages. They're routed to our on-call team, the CI quality enablement team. And the reason that's the case is because these are not generally actionable by the test owners. They don't know why. So system-wide changes, library upgrades, intermittent like infrastructure issues and stuff like that. I'll have some issues there. P1s and flaky tests, they are routed to test owners. So these 2 classes, they have separate custom logic, and then we kind of look at grouping them, deduping them. When a ticket finally gets created, if it's a P1, we exclude the test from developers needing to run it on their merges. We alert their team on call, and if there is a lower threshold P2 flaky test, we close it out. For P2s, we don't exclude the test. We don't alert team on call. This is kind of more of a data gathering exercise, but it is an actionable. The data becomes actionable. Next slide. So adding on to that core functionality, obviously we have out of SLA reminders, groupings, multiple thresholds, multiple outcomes. These are the P1s and P2s, or P1s and flaky tests. I don't like the term P2s, and now it's there. So we also have dedupe logic, and obviously, if there's a CI incident, how do we recover gracefully? When the ticket gets raised, we need to automatically close out the ticket, make sure tests don't get investigated. Developers don't spend time wasting time for something that's not flaky and their fault. So developers who merge their code benefit from test skipping. They also benefit from the exclusion of known flaky tests. Such optimizations aren't present in the monorepo main branch. When we realizing that data from each of these 2 different data sets is very valuable for configuring our thresholds and teasing the perfect quantity of how many flaky tests we actually want to roll out to teams. Non-obvious signals like test runtime, rerun percentage, and minimum test runs, they also really provide good signal to noise ratio. And obviously it's important to remove noise, unmerged, tests from unmerged branches, kind of obvious, and new tests, which are mature. Next slide. So let's dive in more about the features that we consider. Auto Guardian, what do we care about? So the rerun percentage, right? How many reruns need to occur before a ticket is filed? To maintain stability, we offer all CI runs an automatic, like free retry, call it internal retry. We count its utilization, obviously, into our test rerun statistics and flakiness programs. So it increases engineering velocity, but it gives us that necessary data for these flakiness mitigation programs. Then we look at look back period, how far do we want to query the data, the batch size, how impactful of data do we really care about? We'll talk about some examples going forward, and the minimum runs, how mature is the test? All right, let's look at some examples. So here we have a build suite failure. What do we care about? In this case, we care about 2 consecutive failures in the last 15 runs. We don't care about the last 200 runs. We don't care about necessarily one-off failures per se. because yeah, anyway, so once it triggers, we file the P0, it gets routed to our CI team. Next slide, thank you. Then we look at the corpus of tests that we have, the 108,000 tests. They can be excluded by AutoGuardian in our, our builds in our tooling. This flakiness threshold looks at how mature is the test, and the rerun rates in mainline versus like merged feature branches. We care all about that. Once we reach that flakiness threshold, we file a P1. It must be fixed within a given SLA. In our case, it's 24 hours, business hours, and we have reminder automation to ensure that teams actually get it done. So next slide, thank you. For less flaky tests, we still care about mature tests, but obviously the sensitivity thresholds are lower. So we have high test coverage. But we continue to maintain the high test coverage because it's not excluded, but we have increased patterns for teams to dive down and for us to actually explore as well. Next slide. This, so our goal was to increase the trust that our developers had in the CI system and test as a whole. But we also had to achieve the main goal of staying efficient and staying efficient. So flakiness thresholds, they're unique to the team and the teams that work on the code base. Multiple teams, single code base. So we look into alert fatigue, very important. We evaluate the positive and the negative data. We adjust the goals. We adjust the flakiness threshold by monitoring the quality of the goals that are done by the teams. Do they fix the tests? Do they stay fixed? And do they stay stable? Do they get ignored? Do they get disabled and fixed later? Do they get yeah, those are some of the examples. Let's move on. So what did we learn? Alert fatigue really impacts the quality of the outcome. Teams can only take so much input before they start doing bad things, bad quality things. Also, having audit mode is very important. You can't necessarily predict CI systems. Well, I'm not going to say that. You can't. You need to run audit mode for your tooling to ensure that you get the right level of, tests that get kicked out and flagged as flaky. For the bottom, for part 2, set your expectations, communicate them broadly so people understand what you're doing, why you're doing it, how you're doing it, to what extent as well. Move on. So toward the end of the program, when we parsed the outcome, we figured that when we took into the account of alert fatigue, teams were able to double the rate of test stabilization fixes that they performed on initial investigation within SLA. So teams were able to implement test stabilization fixtures at nearly double the rate. Additional positive sentiment from developer surveys reflected improved productivity as a whole, so they weren't complaining. So next up, we'll talk about the business structure. Now that we know the problem, it's how do we get support for it? How do we gather funding? How do we visualize the problem? How do we visualize our progress? Next slide, thank you. So mapping organizational hierarchy is really important, but it's kind of tricky because reorgs are common, but the folks who own the tests they don't change that frequently. So our teams built out mappings to capture in our dashboards to capture the quick vantage point and find areas for improvement at a team by team basis. We're looking in the diagram, looking at the diagram, multiple areas of the code can belong to a single team or can belong to a single module, a single team, and so forth and so forth. So going down, it's critical to find people now. This is the people component. It's critical to find people who are competent in the problem space, who care about it, who want to do the right thing. So these are your, internal champions. You want to solicit feedback from them. You want to listen to them. You want to reward them. You want to understand what they're doing, why they're doing it, and so forth. Bring excitement by gamifying it. Competition, it's fun too. So we remember, all work is urgent. All work has an SLA. So you need to fight for your work, flaky test mitigation, to be on that proper pedestal. So design your incentives accordingly. So let's put this together. Tickets from Auto Guardian, they build the components for the dashboards. That's fully automated. It's very data driven. And the test ownership is dynamically remapped every time reorgs happen. So next slide. So I introduced trust in the conversation. So we introduced the CI system incident calendar. Let's say, so any configuration that we change that we know will impact people, we let them know ahead of time, or we try to. And we also tell them, it's like, if there's infrastructure issues or library upgrades, and if something went wrong, we file it, we publicly have an RCA that, they can join and kind of air their complaints. So we try to fix the reputation of the CI system. So data visualization through the org's lens. Let's look at some dashboard. We'll look at the dashboards actually. So we want to identify the best performing teams, the worst performing teams, and we want to source. And we also want to use that data to source generic framework level fixes that fix many tests in one suite, right? Race conditions, non-parallel safe tests, complex permutation testing and stuff. So all these optimizations, they were implemented across the entire code base, and that would not have been possible without having a silent flaky test level. Something really cool happened, which is executive sponsorship kind of started following in when they saw, hey, we dedicate X resources or X time to this, we actually can see it. We actually can see our teams perform better than others. Cool. Recognize and socialize. So we log data. We want to shout out the folks that do the good work. We want to we want to parse their fixes, especially if they're kind of complex, and we want to distribute and socialize that out to the broader organization. We want to recognize the folks, so forth. So along with that, we also financially recognize them. At Okta, we have a nice little appreciation program. I was able to bootstrap a $25 lottery that test stabilization fixes. All of them were entered into, and once a month or whatever, I would throw all the names into it, and some people get some relatively small amount of financial rewards, but it did help incentivize them. And then obviously we have newsletters. So we talk about the fixes and the people doing the fixes, the type of fixes in the newsletters, and distribute them widely. Let's look at the dashboards. So how many urgent flaky tests were logged? That's kind of obvious. How many flaky tests were escalated to urgent? So this kind of gives a causal relationship potentially that teams can explore. And how long did it take? I actually really like the last one, because if you look at the data, it's like it says an average of 2 weeks, a flaky test becomes an urgent test. I don't know how much of these flaky tests, actually 20% of flaky tests become urgent tests within 2 weeks. Pretty cool data. So we share it out. And for the teams that want to be proactive about it, they can do it. We also want to share the bad data. The teams that are, kind of like what happens with these flaky tests. How do the teams respond? How are teams slower to respond than others? What do they do with these tickets? They just not even close them out, which is a perfectly valid thing to do. You investigate the issue. There's nothing actually wrong from your analysis, and you go off. we have a grace period for flaky tests in our reporting. So, we give them that grace period, but we do throw those tests back into active mode. And those tests can, if they are flaky, they will block developers. So you can kind of discover also what teams need the most help. Look at that team, look at that green team, quarter of the test by that one team. Insane. I don't know who they are. We talked about disable tests. So we started tracking disable tests really tightly. Previously, it was just kind of a passive dashboard that people could access, but it wasn't widely accessed in our CI system. Now we know, what tests were newly disabled. That's that second column on the top graph within the month. Which ones were fixed? Which ones were and which ones were pending disablement? We also look at the test types. So people say, "Hey, integration tests are more flaky." So, I mean, maybe, but look at your API tests. 48% of flaky tests, or 48% of the tests that are disabled are API tests. So, that allows more accurate conversations to be spurred with the organization. Next slide. And then obviously, let's look at the tests that get stabilized. What rates are they? And the individual engineers. Three engineers? Yeah, 3 engineers make up 3/4 of the fixes. I mean, some of them are on this project, but not many. So are they particularly interested in this? Are they really good at fixing this? What's up with that? Next slide. So final takeaways, alert fatigue really impacts the quality of the outcomes. So build in flexible configuration settings into your toolings. It's imperative to use data and show the data, broadcast it out, the what, the how, the where. Pictures are worth 1,000 words, so make it really easy and digestible, not just for engineers, but for TPMs, everyone that can look at these dashboards, the more eyes, frankly, I think the better. No one wants to be in last place as well, competition. And then create a medium for shout outs and recognition. If you have some money that you can take from your VP, please do that. That's a wrap.
We can do one question, and then I think it's time to get out of the really hot room and go to lunch.
So, like, that's.
So can you come out forward for the few people who are on the call? Yeah, that should be good. That's pretty easy.
So often flaky tests share root causes, so they'll flake at the same time because, for example, the database is down or something like that. I just wondered whether that figured into your system and your thinking. I picked it up at points that maybe it did, but I didn't quite.
Yeah, no, absolutely. I'll dive in a little bit. So for this, we have kind of this. I would say is more like a P0. Like if a data breaks a lot of things, there's a high likely chance that the build will break, and like the build suites will break. So we call that a P0, and that gets routed to our CI team, and we kind of figure out who to route. We find who the culprit is, and get them to fix it or fix it ourselves. That makes sense? Not really.
Do you escalate it to the developers together? Like
Yeah. So the question was, do I escalate the tickets together to the developers? After deduping them, yes, we do. Right. So the system dedupes them. And if it's 5 failing test suites or build suites, we throw those all to the developers and be like, hey, fix this. We help them as much as we can as well. Thank you.
Sharon.